NASA's Moonshot, nuclear reactor on the lunar surface by 2030, explained. Imagine a future where humans can thrive on the moon, with a reliable source of power that can sustain life and exploration for extended periods. This vision is becoming a reality, as NASA plans to build a nuclear reactor on the moon by 2030. A move that could revolutionize space travel and exploration. But here's where it gets interesting. This ambitious project is not just about advancing technology, but also about geopolitics and the new space race. The US Space Agency's decision to fast-track the construction of a nuclear reactor on the moon is part of its broader goal to establish a permanent human presence on the lunar surface. However, this move has sparked controversy, with some scientists questioning the realism of the goal and the potential risks involved. As the world watches, nations like China, Russia, India, and Japan are also racing to explore the moon's surface, with some planning to establish permanent human settlements. The idea of building a nuclear reactor on the moon is not new, but it has gained momentum in recent years. In 2022, NASA issued contracts to companies to design a reactor. And in May this year, China and Russia announced plans to build an automated nuclear power station on the moon by 2035. Many scientists agree that nuclear energy is the best, if not the only way, to provide continuous power on the lunar surface. Given the harsh conditions and limited sunlight, a typical lunar day is equivalent to 4 weeks on Earth, with 2 weeks of continual sunshine followed by 2 weeks of darkness, making solar power a challenging option. Dr. Songwoo Lim, a senior lecturer in space applications, suggests that building even a modest lunar habitat would require megawatt-scale power generation, which cannot be reliably met by solar arrays and batteries alone. Nuclear energy is not just desirable, it is inevitable, he adds. However, there are also concerns about safety, with the launch of radioactive materials through the Earth's atmosphere posing significant risks. Dr. Simeon Barber, a planetary science specialist, notes that while it is not insurmountable, it requires special licenses and careful planning. The announcement of the nuclear reactor project has also raised questions about the motivations behind it. Some scientists believe that it is driven by geopolitical goals. Rather than purely scientific objectives, it seems that we're going back into the old first space race days of competition, which, from a scientific perspective, is a little bit disappointing and concerning, says Dr. Barber. The US Transport Secretary Sean Duffy has called for proposals from commercial companies to build a reactor that can generate at least 100 kilowatts of power, a relatively small amount compared to the 2 to 3 megawatts generated by a typical onshore wind turbine. But here's the thing. The plans for the nuclear reactor are not just about providing power, but also about establishing a presence on the moon and potentially claiming ownership. The Artemis Accords, signed by 7 nations in 2020, establish principles for cooperation on the moon's surface, including the creation of safety zones around operations and assets. However, some scientists worry that this could lead to a keep-out zone mentality, where countries claim ownership of certain areas and restrict access to others. As the world watches the new space race unfold, it is clear that the stakes are high and the implications are far-reaching. Will the construction of a nuclear reactor on the moon mark the beginning of a new era in space exploration, or will it lead to a new era of competition and conflict? The answer remains to be seen, but one thing is certain. The future of space travel and exploration will be shaped by the decisions we make today. And this is the part that most people miss. The real challenge is not just about building a nuclear reactor, but about creating a sustainable and equitable presence on the moon that benefits all humanity. So we ask you, what do you think about the plans to build a nuclear reactor on the moon? Do you think it's a necessary step for advancing space exploration, or a risky move that could lead to unforeseen consequences? Share your thoughts in the comments below. Why NASA wants nuclear reactors on the moon before China, the new space race explained. The United States must prioritize establishing nuclear reactors on the moon before other nations take the lead, asserts Sean Duffy, the acting NASA administrator and transportation secretary. This initiative is deemed essential for advancing America's space exploration ambitions and ensuring national security. Duffy's directive, which was shared with ABC News, emphasizes the urgency for the US government to act swiftly in constructing these reactors to stay ahead of its global competitors. A lunar day consists of 2 weeks of sunlight, followed by about 2 weeks of darkness, as measured by Earth time. The directive refers to nuclear energy as fission surface power, FSP, highlighting it as a sustainable and high-powered energy source capable of enduring the harsh conditions of the lunar night. Moreover, this technology could potentially be utilized on other celestial bodies, such as Mars. We are in a competitive race to the moon, particularly with China, Duffy remarked during a press conference on Tuesday. To establish a base on the moon, we require a reliable energy source. While solar power will be harnessed in certain prime locations, the development of this visionary technology is crucial. We have invested hundreds of millions of dollars in research to make this happen. Duffy further stated, "Can we achieve this? We are now transitioning from the planning phase to actual implementation. We have received the green light to proceed. It's time to deploy our technology and turn this vision into reality." When ABC News sought comments from NASA, the agency responded, "We will allow these directives to speak for themselves." The directive, dated July 31st, mandates the appointment of a fission surface power program executive within 30 days. This individual will be responsible for overseeing the project and will report directly to the NASA administrator. However, the directive does not specify what the nuclear reactors on the moon would power. Duffy noted, since March 2024, China and Russia have publicly announced their collaborative efforts to place a reactor on the moon by the mid-2030s on at least 3 occasions. The first nation to achieve this could potentially establish a restricted zone, which would severely limit the United States' ability to set up its planned Artemis presence if we do not act first. In addition to this directive, Duffy issued another on the same day, aimed at accelerating the development of successors to the International Space Station, which is scheduled for retirement by 2030. Although NASA has never deployed a fission nuclear reactor in space, it has utilized nuclear materials for spacecraft power since the 1960s. These systems, known as radioisotope thermoelectric generators, RTGs, convert the heat from plutonium-238 decay into electricity, powering various spacecraft and rovers. For instance, NASA's Curiosity rover on Mars currently operates using an RTG system. In recent years, significant investments have been made in developing small modular reactors, SMRs, a new type of nuclear reactor. While these reactors generate less power than traditional models, they are much more compact. Currently, SMRs are still under development in the US, with no operational units yet. Duffy concluded, "There is a specific area on the moon that is widely recognized as the most advantageous. It contains ice and receives ample sunlight. Our goal is to reach that location first and claim it for the United States."